Hello everyone, welcome to this fascinating exploration of energy and its impact on our world. Today, we're exploring coal, that seemingly simple, yet incredibly powerful black rock. For over a century, coal was the undisputed king, the black rock that powered our world. It fueled the Industrial Revolution and shaped the landscape of modern society. It lit up cities, transforming darkness into a vibrant tapestry of light. It ran factories, driving production and creating the goods that defined an era. Coal was instrumental in building the modern world we know today, laying the foundation for unprecedented growth and progress. But the story of coal isn't without its shadows. Burning coal comes with serious side effects, consequences that we can no longer ignore. The impact on our air, water, and climate is undeniable, presenting us with challenges that demand immediate action. Now, we stand at a crossroads. The world is moving away from coal, recognizing the urgent need for change. We are actively searching for cleaner, healthier energy sources that can power our future without compromising the health of our planet. This shift is driven by science, which provides us with the knowledge to understand the consequences of our actions. It's also driven by economics, as renewable energy becomes increasingly cost competitive. And crucially, it's driven by a global push for sustainability, a collective commitment to creating a better future for generations to come. We're building new power plants that harness the sun's energy, transforming sunlight into electricity. We're capturing the power of the wind, using towering turbines to generate clean, renewable energy, and we're tapping into the Earth's heat, utilizing geothermal energy to provide a sustainable source of power. This transition is one of the most important stories of our time, a narrative of change, innovation, and hope. In this video, we'll dive into how coal works, exploring the science behind its energy generation. We'll examine why it was so popular, understanding its historical significance, and why it's now fading from prominence. We'll look at the science behind coal's impact, the profound effects it has had on our planet, and what's coming next in the world of energy, exploring the innovative technologies that are shaping our future. Get ready to discover the great global shift away from coal, a movement that is transforming the way we power our world. So, buckle up and let's begin our energy adventure, exploring the past, present, and future of power generation. Ever wonder how coal powers your lights or computer? It's all about turning heat into electricity. Coal arrives at a power plant, gets ground into powder, and is burned in a massive furnace. The heat boils water, creating high-pressure steam. This steam spins a turbine. Think of a giant pinwheel. The spinning turbine drives a generator which creates electricity. The steam cools, turns back into water, and the cycle repeats. That's how a lump of coal becomes the electricity that powers your world. Simple, but with big consequences. Not all coal is the same. It's a common misconception that coal is a uniform substance. In reality, coal is a diverse group of sedimentary rocks, each with its own unique characteristics and properties. These differences arise from the varying conditions under which the plant matter was originally deposited and transformed over millions of years. There are 4 main types, each representing a different stage in the coalification process. This process involves the gradual transformation of plant matter into carbon-rich coal, driven by heat, pressure, and time. The 4 primary classifications are lignite, subbituminous, bituminous, and anthracite, each with unique properties making them suitable for different applications and uses. These properties include moisture content, carbon content, energy density, and sulfur content. Understanding these differences is crucial for determining the best way to utilize each type of coal. Lignite, or brown coal, is the youngest and most immature form of coal. It represents the initial stage of coalification, where plant matter has only partially transformed into carbon. It is the youngest and softest, characterized by its high moisture content and relatively low carbon content. This gives it a distinctive brown color and a crumbly texture. With lots of moisture and low energy, lignite is the least energy-dense of all coal types. Its high moisture content makes it less efficient to burn, as energy is required to evaporate the water before combustion can occur. Subbituminous coal represents a further stage in the coalification process. It is a step up from lignite in terms of carbon content and energy density, is older, drier, and produces more energy, making it a more desirable fuel source than lignite. The lower moisture content contributes to its higher energy output. Common in the western U.S., subbituminous coal is a significant energy resource in states like Wyoming and Montana. Its abundance and relatively low sulfur content have made it a popular choice for power generation. Bituminous coal is a higher-rank coal formed under greater pressure and heat than lignite, and subbituminous coal is the most abundant, hard and shiny, making it a widely used fuel source around the world. Its higher carbon content gives it a characteristic black color and a glossy appearance. Great for electricity and making steel, bituminous coal plays a crucial role in various industrial processes. It is used to generate electricity in power plants and as a reducing agent in steel production, but often high in sulfur, which can lead to environmental concerns if not properly managed. The sulfur content of bituminous coal can vary depending on its origin, and burning high sulfur coal can release sulfur dioxide into the atmosphere, contributing to acid rain. Anthracite is the highest rank of coal, representing the final stage of coalification. It has been subjected to the most intense heat and pressure over millions of years, is the oldest, hardest, and burns the cleanest, producing the least amount of smoke and pollutants compared to other coal types. Its high carbon content and low volatile matter make it an efficient and environmentally friendly fuel. But it's rare and expensive, making it less widely used than other types of coal. The limited availability of anthracite and the higher cost of mining and processing contribute to its premium price. Each type has shaped where and how coal is used around the world, influencing regional economies and energy infrastructure. The distribution of different coal types has played a significant role in the development of industries and power generation facilities in various regions. Lignite is mined near the surface, often in large open-pit mines, due to its shallow depth and unconsolidated nature. This makes it relatively easy and inexpensive to extract, and used locally, typically in power plants located near the mines, to minimize transportation costs. The low energy density of lignite makes it uneconomical to transport over long distances. Subbituminous is popular, particularly in the United States for electricity generation. Its lower sulfur content compared to bituminous coal makes it a more environmentally friendly option, for its low sulfur and higher energy, making it a cost-effective and cleaner-burning alternative to bituminous coal in some applications. This has contributed to its increased use in recent years. Bituminous powers industries and homes globally, serving as a versatile fuel source for a wide range of applications. It is used in power plants, steel mills, cement factories, and even for residential heating in some regions. Anthracite's clean burn made it a favorite for heating, especially in densely populated areas where air quality is a concern. Its low smoke and particulate emissions made it a desirable fuel for residential heating in the past. Though it's now used less due to its higher cost and the increasing availability of alternative heating sources like natural gas and electricity, the decline in anthracite use reflects a broader trend towards cleaner and more affordable energy options. Understanding these types helps explain coal's role in history, from powering the Industrial Revolution to providing heat and light for homes. The different properties of each coal type have shaped its specific uses and its impact on society, and why some are fading faster than others as the world transitions to cleaner and more sustainable energy sources. The environmental concerns associated with coal combustion, particularly greenhouse gas emissions, are driving the shift towards alternative energy options. The quality and location of coal deposits have always been key factors in determining their economic viability and utilization. Coal deposits that are easily accessible and of high quality are more likely to be exploited, have always influenced energy choices, shaping the energy landscape and driving technological innovation. The availability and cost of different energy sources have always been central to energy policy and investment decisions. But now, cleaner options like solar, wind, and geothermal energy are becoming increasingly competitive, challenging coal's dominance in the energy sector. The falling costs of renewable energy technologies and the growing awareness of climate change are accelerating the transition to a cleaner energy future, are changing the game, paving the way for a more sustainable and environmentally responsible energy future. The transition away from coal and towards renewable energy sources is a complex and multifaceted process, but it is essential for mitigating climate change and ensuring a healthy planet for future generations. Coal was king because it was reliable, cheap, and abundant. Power plants could run non-stop, providing steady electricity crucial for hospitals, factories, and homes. The coal industry created millions of jobs, supporting entire communities. Using local coal meant energy independence and economic growth. The infrastructure, mines, railways, power plants was already built. For developing countries, coal was the fastest way to electrify and industrialize. For decades, coal was the backbone of progress. Coal's dark side is pollution. Burning coal releases soot, sulfur dioxide, and nitrogen oxides, causing smog, acid rain, and health problems like asthma and heart disease. Mercury from coal ends up in water and fish, harming people, especially children. Coal is also the biggest source of carbon dioxide, a greenhouse gas driving climate change. The result? Rising temperatures, extreme weather, and melting glaciers. Coal plants are also inefficient. Most energy is lost as heat. Newer technologies are cleaner and more efficient. The environmental and health costs of coal are too high to ignore. That's why the world is searching for better ways to power our lives. The age of coal is ending for good reason. Let's take a closer look at how the story of coal is unfolding on a global scale. We're going to examine the energy landscapes of 3 of the world's most influential nations, each grappling with its own unique set of challenges and opportunities in the transition away from coal. We'll focus on China, India, and the United States. These countries represent a significant portion of global energy consumption and carbon emissions, making their energy choices crucial in the fight against climate change. China built its economic boom on coal, relying heavily on this fossil fuel to power its rapid industrialization and urbanization. For decades, coal was the engine of China's growth, fueling its transformation into a global economic powerhouse. Coal was instrumental in powering factories, driving manufacturing output, and illuminating the sprawling cities that sprung up across the country. It provided the energy needed to sustain China's remarkable economic expansion. But this reliance on coal has come at a steep price. China now faces severe air pollution, with many of its major cities shrouded in smog, posing significant health risks to its citizens. The environmental consequences of coal consumption are undeniable. Recognizing the urgency of the situation, the government is making substantial investments in renewable energy sources like solar and wind power, as well as exploring nuclear energy as a cleaner alternative. These efforts aim to diversify China's energy mix and reduce its dependence on coal. However, despite these efforts, China still continues to build new coal plants to meet its ever-growing energy demand. This highlights the complex balancing act between economic growth, energy security, and environmental protection. India, another rapidly developing nation, relies on coal for over 70% of its electricity generation. Coal remains the dominant fuel source for powering India's homes, businesses, and industries. India is leveraging its domestic coal reserves to fuel its economic growth and drive development across the country. Utilizing these resources is seen as a crucial step in achieving energy independence and meeting the needs of its growing population. Access to electricity is a fundamental requirement for improving living standards, and coal has played a vital role in bringing power to millions of people in India, particularly in rural and underserved communities. However, like China, India is also grappling with the challenges of air pollution and the growing threat of climate change. These environmental concerns are prompting a re-evaluation of India's energy strategy. As a result, India is actively expanding its capacity for solar and wind power, recognizing the potential of these renewable sources to provide clean and sustainable energy for the future. The central challenge for India is clear. How can the nation continue to grow its economy and lift millions out of poverty while simultaneously cleaning up its energy sector and reducing its carbon footprint? This is a complex and pressing question. In the United States, coal once reigned supreme as the dominant source of electricity, powering the nation's industrial revolution and its subsequent economic growth. However, the energy landscape in the U.S. has undergone a dramatic transformation in recent years. Natural gas, wind power, and solar energy have emerged as increasingly competitive alternatives to coal. In many regions of the country, these renewable energy sources are now cheaper and cleaner than coal, making them an economically attractive option for utilities and consumers alike. The shift away from coal in the U.S. has been further accelerated by stricter environmental regulations aimed at reducing air pollution and carbon emissions, as well as the rapidly declining costs of renewable energy technologies. These factors have combined to create a challenging environment for the coal industry, leading to the closure of hundreds of coal-fired power plants across the country. As a result, coal's share of U.S. electricity generation has dropped sharply, with renewable energy sources steadily gaining ground and playing an increasingly important role in the nation's energy mix. While each country is navigating its own unique path in the energy transition, influenced by its specific circumstances and priorities, the overall trend is unmistakable. coal is losing ground in the global energy market as cleaner and more sustainable alternatives become increasingly viable and attractive. The world's biggest energy consumers are increasingly shifting towards cleaner energy sources, driven by concerns about climate change, air pollution, and the long-term sustainability of fossil fuels. The era of coal dominance is drawing to a close, marking a significant turning point in the history of energy production and consumption. This transition is happening even in regions where coal once seemed to be an unstoppable force, highlighting the power of technological innovation and changing societal priorities. The future of energy belongs to renewables, paving the way for a cleaner, more sustainable, and more resilient energy system for generations to come. The shift from coal is no accident, it's driven by action. Governments set strict pollution limits, making coal plants expensive to run. Carbon taxes and cap-and-trade systems put a price on pollution, making clean energy more attractive. Incentives and targets for renewables fuel investment and growth. International agreements like the Paris Agreement push countries to cut emissions. Banks and investors are pulling money from coal projects. These combined forces are speeding up the transition. Coal is being replaced by cleaner, smarter power. As coal fades, solar and wind are taking over. Solar panels and wind turbines are now cheaper and more efficient than ever. Massive solar farms and powerful wind turbines generate clean electricity at scale. Battery storage solves the problem of variable sun and wind, keeping the grid reliable. Geothermal, hydropower, and advanced nuclear are also part of the clean energy mix. These technologies are building a resilient, pollution-free energy system. The cost of renewables keeps falling, making them the top choice for new power. Clean energy is now the engine of progress. The world is moving beyond coal, fast. The future is bright, clean, and sustainable. A world without coal means cleaner air, healthier people, and a safer climate. But the transition must be fair, supporting workers and communities that relied on coal. Job retraining and economic investment are essential for a just transition. The energy grid needs upgrades and storage to handle renewables. Developing countries need help to leapfrog to clean energy. This is more than a technical shift. It's a new way of thinking about energy and responsibility. Governments, businesses, and communities must work together. The journey is complex, but the rewards are huge. Science shows us the path. Now it's up to us to build a cleaner future. Let's power the world without coal.